Hello everyone and welcome to my channel. In this video I would like to show you how to create a minimal bare bones FreeBSD machine from scratch. Alright, let's do this. Before we start, let's just discuss a little bit about the plan of action. I'm going to create a FreeBSD machine with an ID disk with a GPT, meaning a GUID partition table, which is a modern version of the MBR, the master boot record from the old days. And the machine is going to be running on Intel x86 64 bits. We are going to create a machine in the following steps. First, we're going to prepare an empty disk, just a bare bones, full of zeros. We're going to create a partition table. We're going to make the disk bootable and also create the UFS partition where our main system is going to live, copy and set up minimal files to boot the system up, and finally boot the system. In this picture I show you the geometry of the disk. We're going to get a disk of about 500 megabytes, which is going to be way too big. The first partition is going to be 512 kilobytes. This is going to be the boot, the FreeBSD boot partition. And the other partition, which is about the 500 megabytes, it's going to be running, it's going to have a FreeBSD UFS file system. For this, I'm going to use a file in the machine that I'm going to use to create the disk. And I'm going to use the loopback device. And the first partition is going to be called MD0 partition 1 and the lower one MD0 partition 2. To boot up the system, I'm going to use QEMU with the disk as IDE, meaning that inside the QEMU, when the machine is booting, the name of the disk is going to become ADA0 partition 1 for the first partition and ADA0 partition 2 for the second partition. This is going to be important for later on. Now let's have a look at the absolute minimum files that I'm going to be placing in the disk. And you see here the structure. We have the root file system. Underneath we have the directories bin, boot, dev, etc. and libexec. Under bin I'm going to create a minimal init system that you see here. I wrote a C code for this, so it just opens the dev console, binds this into the file descriptors for standard input, standard output, standard error, and just calls /bin/sh in interactive mode -i. I'm going to copy a sh file, so you can see here the /bin/sh, and for that I'm going to use sash, which is called a standalone shell. The benefit of the standalone shell is that it's compiled statically and therefore does not require any dynamic libraries. As you see here, I'm not copying any dynamic libraries except for the libexec ld-elf-.so.1, which is required by the loader. In the boot directory, we have a file, the loader and the kernel. The loader is going to load the kernel, and the kernel is the FreeBSD kernel. I'm not going to compile an optimized version of the kernel, but you can believe me that you can reduce the size pretty much. But here I'm not going to do it. And I'm going to mess around with the Lua script. So the loader calls the loader.lua, which is actually a very interesting way that FreeBSD loads nowadays. So it calls the loader.lua, and this is what makes the menu where you can select, so in the beginning you have a boot menu and so on, and this reads some variables from /boot/loader.conf or /defaults.loader.conf. And because I don't have those things, I set the variables directly in Lua. And for that, inside this, I'm going to do a loader setenv, and this would go again to the /boot/loader.conf, and this would be init path equals /bin/init. So I want to initialize the system by calling this init file. The console is going to be a serial port, com console, and after doing the setting of these variables, I'm just going to load the kernel, which is located at /boot/kernel. The /dev currently is in red, so we're going to see which devices I'm going to create. In the /etc, I'm only going to place the FS tab. And now with the magic of video editing, this should be fixed. And the FS tab is just going to say that in /dev/ada0 partition 2, you remember from before, this is our root file system with UFS, and we want to mount it read write. What am I going to place under dev? Here you can see. Under dev, I'm going to place the null, 0, console, TTY, standard in, standard out, standard error, and FT0, 1 and 2. To get these devices, I'm going to use mknode, so mknode null for the character device with 019. So those are the parameters, as you can see here, and the standard in, out, and error is going to be a link, a static link to the FT012. Okay, so enough of theory. Let's get this party started. So here So I'm going to log into the machine, SSH Kaziba at 192.168.284. And we're going to get a shell. Okay, now we get a root user. And I'm going to create a directory. I'm going to call it test. And let's go to the directory test. So currently there is nothing here. So let's start with the first step. Let's prepare the image. So for that, dd, we get from dev0, and we get the name minimal.img. Let's put 512 megabytes should be enough. So count equals 512, and now we have the machine here. So the disk here, sorry, 512. Now let's use a loopback device. So mdconfig tvnode in this file, and we created the device md0. gpart show md0 should say, okay, you don't have a geometry, so let's create a geometry. gpart create gpt on md0. And now we have the geometry. Now let's add the two partitions. gpart add 4K 512K -s 512K FreeBSD boot md0 gpart add Okay, so now our disk has in md0 has the boot partition 512 kilobytes and the UFS file system, which is not yet formatted. So let's let's do that, and we need to make it bootable. So actually, let's start with the bootable part. So let's use gpart here. Okay, so the partition code is the part code is written to md0p1 and the boot code to md0. Now let's format the UFS file system. Okay, so now it's formatted and we can mount a disk. So mkdir -p mnt minimal. We create a minimal directory and then mount dev md0 p2 to mnt minimal. So that should be it. and it's mounted. Now let's start creating the directory structure. So mkdir -p mnt minimal. We need the directory bin. We need the directory etc. We need libexec. We need dev. Oops. Okay, we remove the directory we don't need. Now let's copy the libexec. By the way, yes, I am running on an AMD 64, so x86 64 bits. I've installed this before, but you can just pkg install sash. So it's already installed. Which sash? This is in user local bin sash. And let's copy this into mnt minimal bin. And this is, I'm going to call it sh. If you don't know, just before we boot the image, let's just run here sash, and it's the standalone shell, so version 3.8, and we can say, so for example, that -ls, and it does a directory listing. Okay, man sash, it's a standalone shell with built-in commands, and this is the nice thing, because we are not going to copy a couple of commands. We are not really going to use them, but we would have AR, DD, CP, echo, grep, file, mount, MV, mknode, rmd, lots of commands here. Yeah, and which SSH and LDD, user, local bin, SASH. This is a static file. It's not a dynamic health. So that's pretty good. Now let's copy the loader. So copy boot loader to mnt minimal boot. Let's copy the boot kernel. Here it's located the kernel to minimal boot. So this is what I'm going to put. It's not exactly the same location, but this is fine. And now we need to create the init script. So let's vim init.c. So let's try that. So here include sys ioctl, include fcntl.h, and let's compile this program. There is a small warning, but I think it compiles. Yes, it compiles and strip. And I think it even reduces a little bit. So it was, 3 megabytes, 3.5 megabytes, and now it's only 600 kilobytes. Cool. So we can have the init running. We can copy the init to /mnt minimal bin. So we're placing it in /bin/init. Let's create the Lua file, mnt minimal put Lua loader.lua. And as we said before, loader.setEnv init path to /bin/init. Loader setEnv console to console loader perform load boot kernel. Okay, so that should be it. Now we need the fs tab. /dev ada0 0p2 is going to be mounted here. UFS read write 11. And let's have a look at our system. MNT minimal. Let's do with -g. So the snap, we don't really need it. I don't know why this is created. So we have the -bin. Let's see. Inside bin we have init and sh. Inside boot we have the kernel, the loader, Lua. Inside Lua we have loader.lua. Inside the dev we don't have anything, but this is going to be populated. Inside the etc we have fs tab, and inside the libexec we have the ld11so.1. How much is this occupying? This is occupying an amazing 28 megabytes, because actually the largest file here is the FreeBSD kernel. Let's have a look at this. So boot and the FreeBSD kernel is taking up 28 megabytes. So this is the largest file. So in the bin we have really very less. And actually, let's see here in bin. Let's strip the sh executable, and it becomes, instead of 3 megabytes, it becomes 1 megabyte. So now it should be even smaller. We don't notice that much difference, but yeah, it's the FreeBSD kernel that takes the most space. No problem. We are ready to rock and roll, to boot the system. So let's just unmount mnt minimal and mdconfig, take out the 0. Now we do a QEMU and we boot the system, and let's see if it boots up. QEMU system. So first we need to change to the directory, and we go to the test directory. I forgot that, so sorry. So QEMU system x8. Let's give the machine 512 megabytes of RAM, which is actually quite interesting. It has as much RAM as disk space, and we don't have graphics. Okay, let's try to boot the machine. Press enter, booting from the kernel. Hey, standalone shell, -ls, that's it. Let me see -du. That's no file. So it doesn't have the du command, but also not uname. Yeah, it doesn't have all the commands, but ls bin. Yeah, we know it's the files are there. So this is the standalone shell, and the system has booted. How nice is that? Why did we do all these things? Because we want to learn about FreeBSD. So that's it for today. If you liked the video, please give it a thumbs up. And if you have some comments or suggestions, please use the space down below. Otherwise, thank you for passing by. Take care, have a nice day, and see you next time.